so for this assignment, we are going to be finding the magnitude of the acceleration and the contact force between these two masses. So to find the magnitude of the acceleration, we are going to find summation of Fx, which is equal to the mass by the acceleration. So looking at this entire setup, you can see that the only force in the x direction is F. So we have F equals to, again, taking in this setup, the total mass is equals to m1 by m plus m2. So to find acceleration, you just do a simple change of subject here. So A is equals to F out of m1 plus m2. So A is done. So for B, to be able to find the contact force between the two masses, we need to resolve each mass on its own, the forces on each mass. So we have m1, which has weight acting downwards, so m1g, and then the normal force acting upwards. And looking here, you can see F is directly acting on m1, so we have F in this direction. Also, m2 is applying a reaction force on m1. So yeah, that is denoted by P, and this is the contact force of m1 applied by m2. So now we resolve the forces acting on m2. So we have weight obviously acting downwards, so m2g, and then the normal force acting upwards. So over here you can see that the force is not acting directly on m2, rather m1 is applying a force on m2, which is denoted by P again, but because this is the contact force of m2 applied by m1, so this is how this is written. Okay, so now we need to resolve these forces acting on m1. So for m1, the forces in the x direction, we have summation Fx, which is equals to F, because F is acting in the positive x direction, minus P21, because that was acting in the negative x direction. So here we have MA, but then we already know what A is equals to. So A is F out of m1 plus m2 equals to F minus P21. So now we make P21 the subject, the contact force, because that is what we are finding here. So to make P21 the subject, we have F minus m1 into F out of m1 plus m2. So now we take F out, so F into 1 minus m1 out of m1 plus m2. So this is what we have for P21. So now we resolve the forces in m2. So you can go back to the diagram and look at how we resolve the forces in m2. You can see that there's only one force acting in the x direction for m2, and that is P12. So we know summation of Fx will be equal to P12. So P12 is equals to m2 into F out of m1 plus m2. Okay, so P12 equals to, can take F out, it's equals to m2 over n1 plus m2. So over here, for what we got for P21, we can simplify this into F goes into m2 out of m1 plus m2. So looking at these two equations, we can tell that these two equations are actually the same. And this is because Newton's third law, if you look at Newton's third law, it clearly states that for every action, there's an opposite and equal reaction, meaning that looking here, you can clearly tell that P12 is in the positive x direction and P21 is in the negative x direction, which means that P12 will be equals to negative P21, because this is the action, this is the equal but opposite reaction. So you just take the modulus of these two to find the magnitude. So P12 is equal to P21. So that's why these equations are the same. So the contact force is simply P equals to F M2 out of M1 plus M2. Okay, so now for the third question. So the third question essentially is saying that if we have this same setup, but okay, so with M1, M2, this same setup. However, in this case, the force is acting on the right hand side of M2, but it's acting towards the left. So this is the force that we have. So the third question is asking, if we have a setup like this, what happens to our contact force? So here we resolve both of them. So we resolve M1. Obviously we have mg and n. So over here you can see that F is not directly acting on M1. However, M2 is applying a force on M1, and that force is going to be in the positive direction. That's bad. In the negative x direction. So that will be okay. So let's denote the contact force for this second scenario as C. So that would be the C of the contact force of mass 1 applied by mass 2. So C21. And then we have this. So in M2, we have the mass M2G and then normal force. Then we have a force acting on it this way. So this is our F, and it also has a force acting this way, which is the C12. And this is just as I explained in the previous situation, that it is the opposite but equal reaction force to the C21 here. So obviously, so for M1, we have summation f of x is equal to summation f of x for M1 will be C21, because that is the only force in the x direction. So C21, and we have M1 into F out of M1 plus M2. And this is because the acceleration doesn't change, even though we have the force acting in a different direction now. Acceleration is still the same, except it changes in direction though, it has the same magnitude. So we have our acceleration is to C21. So C21 is equals to, let's take F out, M1 plus M2. So now we are going to resolve the forces for M2. Positive x direction was equal to negative of the one in the negative x direction, meaning that the magnitudes are the same. So here we have the same thing. So C21 be equals to, C12 will be equals to negative C21. Take modulus of each side, which means C12 is equals to C21, meaning they have the same magnitudes. And so C21 was equals to F M1 out of M1 plus M2. And from the previous situation, what we had was, or the previous scenario, we had P being F into M2 out of M1 plus M2. So we are comparing both of these to know which one, comparing both of these to know which one would be greater, which one would be lesser, essentially. So from just looking at this, you can actually tell which one would be greater, because we've been told previously that M1 is greater than M2 for both situations. So looking at these two formulas, we can see F and F, so those cancel out each other. The denominators are the same, so that cancels out each other. So you can see that C is equals to M1 and P is equals to M2. And it's clearly stated here that M1 is greater than M2. Hence, the contact force hence C is greater than P, meaning that the contact force for the second scenario is greater than the contact force for the first scenario. Thank you.